Hello everyone, welcome back again to a brand new episode of Friction in Chinmoy's Biology channel. So let's get started without further delay. Today is going to be a very interesting lesson, very interesting topic. So don't skip the lesson in between and let's get started with today's episode of Friction. So here we are with today's lesson Friction. This is your chapter 9th of NCERT book. So we have already completed our previous lesson, that is force and pressure. So hope you have gone through that lesson as well, because I'll be putting the link in the description box if you have not gone through that. So let's get started. Now, so there are several things we experience in life that are related to friction. So what are they? So first, we have seen a truck driver slowing down a vehicle in traffic signal, or a car or a scooter, whatever the vehicle is, suddenly it will come and stop in a signal. Okay, so generally when you are on a bicycle, you will slow down, you will apply the brake when you are seeing something in front of you, so you are applying the brake, so your cycle will slow down. So have you ever thought why the vehicle slows down when brakes are applied? So there is a question always in your mind, right? Why a vehicle is slowing down? So not only vehicles, there are other moving objects, okay, so which are when no external force also is being applied on them, it will slow down. Okay, so how does it finally stop? How does it slow down? So have you seen a ball? When you are rolling the ball on the ground, after some time of rolling, it will gradually slow down and it will gradually stop. Now another question is there: why do we slip over a banana peel? And why it is very difficult to walk on a smooth or a wet floor? So generally on a wet floor we will fall when there is water on the ground, the floor is wet, and when the floor is very smooth, generally it is very difficult to walk on a marble floor or a very much polished floor. So why does all these things happen? These questions keep on coming in our mind. So this lesson will give answers to all our questions. So this is a lesson which is based on frictions, which is going to answer all the questions. So please stay tuned throughout the full lesson and don't skip in between. So you will miss all the answers which I'll be discussing during this lesson, right? So let's start. Now here you can see the diagram of a boy falling on when he is stepping on a banana peel. So why these are happening? So force, what is the force of friction? First we will say what is it. So when you are gently pushing a book on a table, so what you will observe, it will stop after some time, after moving for some distance, right? Repeat this activity while pushing the book from the opposite side, the same thing will happen. So can you think the explanation what is happening there? So this is the force of friction, right? It is the force of friction. So what is friction doing? Friction is opposing actually the relative motion between the surfaces of the book and the table. So it is opposing the relative motion. So wherever the book is moving, it is opposing the motion. So that is what is called the friction. This opposing force is called the friction. Now another thing is that you saw that if you apply a force along the left, the friction acts along the right. If you apply the force along the right, the friction will just act in the opposite direction. So in both the cases, it is opposing the force of motion, okay, of the book. So the force of friction is always opposing the applied force. So wherever you are applying the force, it will oppose the force. So in the above activity, we have seen in this activity 1 that in between what the friction was happening, the friction was happening between the surface of the book and the surface of the table. Is it clear? Now, is the friction same for all the surfaces? Does it depend on the smoothness of the surfaces? Let us find out that. So what are the factors which are affecting friction? So we will study this with again few activities. So here we start with the factors affecting friction. So when we are starting with the factors affecting friction, first activity what we can do is we can take a brick here. So we are taking a brick here. We are tying, we can say in the neck of this brick, we are tying one string and we are trying to pull it. Okay, so pull the brake by a spring balance. So this is a spring balance. This I'll discuss later, what is a spring balance and how it is used and why it is used. Okay, so just first let us do this experiment. So note down the reading on the spring balance when the brake just moves towards it. Okay, so it gives you a measure of the force of friction between the surface of the brake and the floor. So you are pulling the brake, you are tying the rope in the middle of the brake, you are attaching that to the spring balance and you are pulling it towards your spring balance side. So this is what is measure of the force of friction between the surface of the brake and the floor. So friction between the surface of the brake and the floor. Now what you are doing, you are trying to wrap this brake with a polythene around the brake and repeat the same activity again and again. So do you observe any difference in the readings of the spring balance in the above two cases? Yes, when you are wrapping a piece of polythene around the neck of the brake, what will happen? The frictional force will reduce. So the friction between the surface and the floor, that is surface of the brake and the floor, will get reduced because you are covering the brake with a piece of polythene. So the frictional force is reducing. So why that is reducing? Because we have told that it depends on the smoothness of the surface. So more the smooth the surface is, the force of friction reduces. That is why when we are walking or we are moving on a smooth floor, it is difficult for us to walk because the frictional force is very less. So when it is less, there are chances to slip over that surface. So that is extremely important point, which is based on the smoothness and roughness of the surface on which the friction depends. Okay, so now we will move on to this. So repeat the activity again by wrapping a piece of jute bag around the brake. So first we have done it normally without wrapping anything. The brake we have pulled with the spring balance, and then we have done with a polythene sheet wrapping around the piece of brake, and third time we are doing the same experiment with wrapping a piece of bag around the neck. So in this case what will happen? The friction will be much better, not as that as high that was happening in the first case, that is in between the brake and the normal surface. Now you are wrapping a piece of paper. The frictional force of a paper is much more than a piece of polythene, because the paper's smoothness is lesser than that of a polythene piece. So when you are pulling it with the help of spring balance, you can see the markings in the spring balance. Just note down the markings, what is the reading, what happened in the first case when you were just pulling along the brake and the surface, second along the polythene bag, and third when you are wrapping it with a piece of paper. So then we can find out the differences between the frictional force, what is measured between the floor and the surface of the brake. Is it clear to all of you now? Now we will see what is spring balance and why is it used. Okay. Now here comes the spring balance, right? So this is what is a spring balance. This you have obviously seen when people who come to buy newspapers from your house, they will be carrying this spring balance. Okay, so what is a spring balance? It is a device used for measuring the force acting on the object. So we can generally hang the object whose weight we want to measure. So they are hanging that. You can hang sacks or anything. So we will just take the reading from here, how many from 0 it starts, so how many markings or readings it is coming down. So that is the measurement. It consists of coil spring here. Coil spring is here and it is stretched when the force is applied to it. Now stretching of the spring balance is measured by a pointer. Here we can see a pointer which gives you the graduated scale pointer which is moving. There are graduated scale on both sides and it will be showing you the measurement or the weight of a substance. So the reading on the scale gives you the magnitude of force. Okay, so spring balance is also used for measuring the frictional force. Is it clear? So here comes another very interesting activity, activity 9.3. This you can do at home also. So make an inclined plane on a smooth floor or a table. So what you are doing, you are making an inclined plane. You can use wooden cardboard, you can use bricks or books. So put a mark with a pencil at the point A on the inclined plane. Okay. Now let the pencil cell, that is the pencil battery. What is a pencil cell? That is a pencil battery which is used in your clock or any other batteries which are used in your remotes. Any battery you can use, that you just slide down along this inclined plane. So how far does it move on the table for coming to rest? Note down the distance. Now this is what you are going to do. So this is a table, on that you have made with a notebook or a piece of cardboard. You have just, with the help of a thick book, you have made an inclined plane. You have marked this position A. From this point you are just rolling this pencil battery over here. So now you are rolling it over the plain table normally. Then you are spreading a cloth on this table, and you are placing the cloth in such a way that no wrinkles are there on the cloth. So it should be without wrinkles. Then try this activity again. What you will see, so this is actually, you are spreading a piece of paper or a cloth like this. You can see here the cell has traveled this much distance, but when you are placing this cloth, it has just traveled this much distance from mark A. So the mark is same, the activity is same, but the difference is on the surface the cell is moving. So first it was a plain surface, then it is a surface on which you have just placed a piece of cloth or a piece of paper. So the frictional force has increased. Okay, so repeat this activity by spreading a thin layer of sand over the table. Maintain the same slope throughout the activity. So the same thing you are doing, again spreading a sheet of sand on that. So this sand, if it is not available near your household, you can just do it in 2 steps only. This is a very easy experiment, and this will show you that the distance covered depends on the nature of the surface, okay, on which the cell moves or the battery is moving. So could the smoothness of the surface of the cell also affect the distance traveled by it? Yes, it can be that, the smoothness of the cell, but in both the cases the cell used is the same. It's not different cell, so the smoothness is same. Only the surface of the this table or on which the cell is moving has been changed. So you can try this by wrapping a piece of sandpaper around the cell also. So what will happen if you are wrapping sandpaper around the cell? The outside of the cell surface will also become rough, so that will also increase the frictional force, and the cell will move less. It will not glide throughout this. So if you are wrapping sandpaper, it will probably move to this distance and stop, because the frictional force will be large in that case. So now friction is caused by the irregularities on the 2 surfaces of contact. So even those which appear very smooth have a large number of minute irregularities in them. So what are irregularities? So irregularities are unevenness on the surface, whether it's the base surface or the object which is rolling. Okay. So when we attempt to move any surface, we have to apply force to overcome the interlocking part. On rough surfaces, there are large number of irregularities, whereas on the smooth surface, it is less. So the force of friction is always greater in a rough surface than a smooth surface. Okay. So you can see here. So this is the surface of a book, and this is the surface of a table. So when you are trying to move this on this surface, both the surfaces are having irregularities, though they are not visible through our naked eye, but they are having. Okay, so these are the surface irregularities which we can't ignore. So for this only, friction will increase or decrease. Okay, so what we have seen here, we see that friction is caused by the interlocking of irregularities in the 2 surfaces. So it is obvious that the force of friction will increase if the 2 surfaces are pressed much harder. So when you can see this example at home very easily, when someone is sitting on a mat, if you are trying to pull the mat, it is very difficult for you to pull the mat or drag it, but when no one is sitting, it is very easy. So when you are pressing hard that mat, the frictional force between the surface ground and the mat will become harder. Now you have to push, you can see here a box is there and you are pushing that. You have to push the box to keep it moving, right? So now recall your experience when last time you moved a heavy box from one place to another. Suppose you are dragging a heavy box from one plane to another. If you have not so much experience, get that experience now. So what is easier to move the box from rest or from motion? So when a box is already in motion, it is much easier to drag it. But when a big box is there at rest, it is much difficult to drag it. So the force required to overcome the friction. So when you are pulling it from the rest position to overcome the friction at that instant, when it is starting moving from the rest, is a measure of static friction. Okay, that is the static friction. You are overcoming that static friction. On the other hand, the force required to keep the objects moving with the same speed is a measure of sliding friction. So two types of friction here we are discussing with. That is, one is static friction. One, when an object is in a static position, from there when you are overcoming that, the force required to overcome is this starts from rest is the measure of static friction. And when an object is already moving with the same speed is a measure of the sliding friction. Is it clear to all of you? So static friction and sliding friction, two important points we have come now to learn. Okay, so this is static friction, this is sliding friction. Now, when the box starts sliding, the contact points on the surface do not get enough time to lock into the contact points on the floor. So they are not getting enough times to lock. So there is an interlocking force, right? So the sliding friction is much smaller than the static friction. Okay, so once it is coming to rest, then they are locking each other. So that is interlocking both the irregular surfaces is difficult. So the static frictional force is much harder, difficult. So you can find that it is somewhat easier to move the box which is already in motion than to get it started from rest. So this is all about the basic concepts of friction. What are the things we need to overcome when we are trying to put a object to motion? So friction, it is a necessary evil. This is very important, and regarding this we are going to discuss in the next topic. So please stay tuned, because in the next video itself I'll be teaching you the friction as a necessary evil. We will also study about all these things, why the soles of shoes wear out due to friction. We will study all this. We will study about the increasing and reducing friction. So to learn all these things, you need to stay tuned to my channel. You need to subscribe to my channel. So to get updated, watch my videos, watch my lesson, and don't skip in between. So you will be knowing all the topics which I discussed throughout the episode. So stay tuned, stay updated, and stay with me. Subscribe to my channel. Thank you. Thanks a lot for watching.